All right, hopefully this doesn't suck. We'll find out. And I'm not editing it because I'm lazy. So first question the cotton ball asked for was number 7. All right, it says for the given functions f and g, find the following and the domain. So here's f, here's g. Neither of them have a restricted domain, so we don't have to worry about that. But if we divide g by f, f can't be 0 because the denominator can't be 0, right? So for my domain, 2x over 5 is not 0. So that means x is not 0, right? Do a tiny bit of basic algebra and you get x is not 0. Did you get that, cotton ball? No, we're solving for monkey. Do you understand? Good. It says find the domain. So this is for the domain. I did that first. Now for g over f, you just literally do g divided by f. I did divided by because it's a fraction. How do we divide by a fraction? Reciprocate and multiply. No running in the hallways, you ninny. You heard me. Okay. Distribute. And there you go. The domain, if you wanted an interval notation, would be negative infinity to 0, union 0 to infinity. It's everything but 0, people. 0 is the only thing not allowed. Next. Next. Nine. Verse 9. Is this 9?
Yeah.
Okay. So intercepts. Well, we got an x-intercept. Nope. But we do have a y-intercept right here of 2. So that's 0, 2. It asks for intercepts. You have one intercept, 0, 2. It's obviously a y-intercept.
Yeah, no. Okay, yeah,
The domain, well, it looks like it's going forever to the left, all the way up until 7. So forever to the left, up until 7. It's got a solid dot, so we're going to include it. Range, let's see, the lowest spot on here looks like 2. And I do have solidness over on 2, so I'm going to include it. Goes all the way up to forever, because it's got an arrow. That's going left and up. Where is it increasing at? Well, increasing, decreasing, and constant. Let's do those all at once, left to right. From negative infinity until around here-ish, we're going down. So that's decreasing. So from negative infinity to negative 4, we're using x values. We're decreasing. We don't include the endpoints because, well, is it decreasing or increasing at negative 4? That doesn't make sense. It's 1 point. Because it's decreasing on this side, then it starts increasing from negative 4 to negative 2. X values only.
We don't put brackets anymore?
Not for increasing and decreasing, at least not how I would consider it. Now, if your teacher did something different, that would be on you. So go look and see your teacher's examples. Personally, I feel like inclusive would not make sense. Okay, we have this sharp point here at negative 2, and then it's going down to 0. Negative 2 to 0. Also, your teacher might have you use unions or commas. Go look at your teacher's examples, see what they want. Justin, go to where you're supposed to be. You're always walking the hall. Constant from 0 to 4. Because I'm American. You Indian. I'm going from left to right so I can not skip anything. Why would we go right to left? I mean, you could. You could. It would just be stupid, but you could do it. Well, no, you'd say, okay, from here to here, it's increasing. So from 4 to 6 or 7 or whatever. Yeah, to go left to right. We're in America, whether you want to be or not. So from 4 to 7, it's increasing. And that's it. That's all it asks for. Yeah.
This is the average rate of change thing.
Oh, woo. Let me check something. La la la. Okay. Sounds working. All right, find the average rate of change. Your formula, remember it. F of B minus F of A over B minus A. That's the average rate of change formula. I even saw it in your notes. So this is A, this is B. This little function right here is F. So let's just do some scratch work. F of 3, 53. What? 27 times 2 minus 1, 53. If you can't plug in a number, you should just take the W. F of 1 is 1. So the average rate of change would be 53 minus 1 over 3 minus 1, which is 52 over 2, which is 26.
Wait. Oh, we put.
You-
Oh, put it into the formula.
Yes, we plug numbers into formula. Where'd I get what from?
3 on the bottom.
B is 3.
And that's 26 the answer.
That's the average rate of change.
Should I just box it or should I put 26 equals average rate of change?
Why don't you go look at what your teacher did and follow what your teacher did for formatting? I'm solving the problem. Your job is to format it. I don't know what your teacher wants. I'm not your teacher. What you doing, Stick?
Okay, proceed to 11.
Number 11. Okay, for number 11, we're going to make an assumption. We're using the same x and y values. All right, now give me the equation for the secant line. I don't remember.
2x cubed.
No.
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 We don't have.
What's the, go look in your notes. What's the equation for the secant line? Yeah, it's like y minus b times the difference in the, it should be like f of b minus f of a over b minus a. Yeah, that's what it should be. It should be y minus b equals f of, but double check. This is just point slope for y minus y equals m times x minus x. So it should be this. I'm certain it's that, but I have no idea what your formula looks like. So you might have different symbols or something. Because your average rate of change will be your slope of your secant line. A and B is one of your points. Whoa. Let's not do A and B. Let's do F of A. That'd be better. That's better symbols. It didn't give you one. Seriously? Okay, well, look at one example that you have of a secant line and see what formula you used. Why are you such a failure, Jasmine? While we're waiting on her to see if she can find something, we're going to go from 1 to 3. So I'm going to go ahead and get f of 3. It's the same function, huh? Yeah, so that's 53. F of 1 is 1. So we literally use this slope right here. Our slope is 26. We already did that. Y minus, and you can pick either order pair, either 3, 53, or 1, 1. I'm going to go with 1, 1 because it's smaller numbers. So this is X, this is Y. This is F of A, this is A. It's just Y minus Y1 equals M times X minus X1. That's the only formula we're using. I don't know how your formula would look on your notes, but that's what we got to do. So Y equals 26, that's not 6, 26 X minus 25. And you'll get the same thing if you use the other point. I'll show you. Instead of 1, 1, we'll use 53, 3.
Okay, I got something. It's a slight, it's a slope of secant line. Average rate of change of a function from A to B equals the slope of the secant line containing the 2 points, parentheses A, comma, F of A, parentheses, and parentheses B.
There you go. Same thing. You see? Negative 25, either one you use. Did you have an equation though? Okay, here's the equation. So you do the average rate of change. Okay. I'm waiting for an affirmation.
Yep.
Okay. So you do the average rate of change. That is the slope of your secant line. So that's what's going to go right here. All we did was this formula. Y minus Y1 equals M times X minus X1. Back from Algebra 1, still here. But our M was this, our average rate of change. X1, Y1, well, that's just a point. We have 2 points that we're assuming that they want us to use because, she didn't actually specify. But based on the homeworks, it looks like you're going to use, the problems are going to follow each other. So we're assuming the same X values, 1 and 3. So we plug those in to find our Y values. This is Y is 53, this Y is 1. And you can pick either order pair you want, 1, 1, or 3, 53. I'd go with the smaller numbers because it's smaller numbers. You plug it in, and you solve for Y. No, 26 times negative 1 is negative 26 plus 1 is negative 25. Jesus. You're still staring at it blankly. Why?
Okay, so wait, which one's F1? F1 is
F of 1 was 1. F of 3 was 53.
okay, so F of A is 1.
So it doesn't matter. We'll go either way. It doesn't matter which order pair you use. We're either going to use 3, 53, or we're going to use 1, 1. X, Y, X, Y. It doesn't matter which way you go. Just pick a point. This point's got smaller numbers. I'm going to pick that one. Next, what?
That's it. That's it.
That's it right there.
Yay.
Let's see if the text emailed me back yet. Nope, not one. All right, so first, what kind of mother function is this, Cotton? It's a cubic mother function. So I'm going to start with that. And I'm going to transform it. So the basic points for the cubic mother function, I'm going to erase these in a minute, so don't do it in pen. The basic points are 0, 0, 1, 1, negative 1, negative 1. I don't know what she's going to have on the test. It just says do it on the same coordinate plane. So here, I grabbed one. Now, we're going to double the y values because it's a stretch vertically by 2. So these guys are gone. Then we're going to shift it down 1. That's a vertical shift down 1. I do it in blue so I can see what the final result will be. So these are our points, and we should know what the cubic mother function looks like. Let me make my points a bit bigger. Also, you have a graphing calculator you could use, right? Right.
Yeah.
And this would be way down here. So this would be like down at negative 17. So we're not going to cross this line. Now we have it's positive 14, 15, something like that. So we're not going to cross that line. That's a terrible arrow, but it's a good one. There.
Wait, what was that crossing?
The next line over, because we doubled the, usually the next point would be 2, 8, and we just doubled that to 16. So we're not, it's not on the graph. Don't cross that line. Now the secant line, we got 26x minus 25. So we need a different graph. 10 by 10 is not good. Shoot. Ten by 10 is not good enough. We got a y-intercept of negative 25. We need that. Well, we don't really need it, but whatever. Let's go bigger graph.
Would you like me to continue doing this during the last hour?
Got done?
I just completed it the first time that I'm doing this.
Then just do it again another time. So we want these 2 points on there. We want those 2 points. Hey, you want coffee? No? You sure? You sure?
You have an extra cup?
Yeah, I got your cup from this morning. I brought it. I brought it from the car here. Say hi to Abby and Noah. He's lazy. That's why he didn't come. So we want to include these points on the graph. I guess you're going to sketch it. Let's just sketch it because it would be significantly easier, I guess. No, well, not really. This is terrible. So I don't know if she's going to give you a graph. Do you have an example? Why don't you look at what she did before and see if she sketched it or what? Because it's going to look something like that, you know, if I sketch it, if I just kind of guesstimate at it, you know, it's going down. That's kind of too fat. Something like that. Something like that. And then I'd put my key points on there. That would be at the, you know, 0, -1. Then we'd have 1, 1. And we'd have 3. What? How do you do a screenshot? You. Wait.
No, how do you send one? I don't know how to take one.
Well, then just upload it. Just like you upload anything else. And then we draw a straight line through those dots. So that's how I would sketch it. I don't know if she's going to want you to sketch it or graph it. If she's going to provide a graph for you, I don't know. But there was no graph provided, so I guess she just wants a sketch. It would look something like that. I don't know. Cotton's looking for an example right now, isn't she? She says she is. I don't believe her.
I put it in a dot. In the hex.
Okay, I'll get it in just a second.
I just took a screenshot from
So
whatever she had.
why'd you put it in a doc? Just upload as an image. Okay, so do you have anywhere it's an actual example instead of just a general example? We're waiting for Jasmine to get an example so we can see what she's going to want you to do. If she wants you to sketch it or graph it. I'll be right back. Oh, so she says use a graphing utility. So I guess just use the graphing calculator. So I'm not quite sure. It says sketch. So to me, a sketch is decently accurate instead of just drawing. So I'd hope she'd provide a coordinate plane for you that was big enough. Maybe one without, maybe if we do one without lines, let's see. And without numbers on it. You can like change the Y scale, count by tens on the Y or something. No. Let's try this. So let's just say we have a blank grid. We're going positives. So I'm gonna do something like this. On the X, I'm gonna count by ones. So I'm gonna label this 1, 2, 3. On the Y's, let's count by 5, 10, 15, 20, 25, 30, 35, 40, 45. I guess we got to count by tens or something. Maybe eights. I don't know. Let's go by fives. Fives would be better. So I don't know how picky your teacher is about this or what, but here's what we need to do. Go back. There we go. Okay. So it's a little gap there, but just deal with it. And that's about right. Sure. Okay, so pretend this gap isn't here and we'll go with it. So we're going to count by fives. Count by ones on the X's. 5, 10, 15, 25, 30, 35, 40. You can always email your professor and ask her what she wants. 55, and that should be good enough. Maybe 60. We'll just go here. All right, so we do want our key points. So we know it's going to be 0, -1, right? That's our inflection point right here. 0, -1, so that's going to be like right here. And then 1, 1, so that's going to be like right here. And then we also have 3, 53. So 0, 1, 2, 3, 53 is about right here. Hey, Mr. Jerry. Making it. And then over here, you know, we'd have -1, -3, so that's like right here. Something like that. So this part's going to go like, this part is going to be extraordinarily tricky to draw. I guess we could make it a little accurate. If we plug in 2, that's going to be 16 minus 1, 15. So right here, might as well try and make it accurate. Yeah. And like that. Sure, terrible drawing. Do better than me. And then let's emphasize these dots right here. 1, 1. And 353. Connect those dots to the straight line because that's your secant line. And that's what I do. So use your ID or something as a straight line drawing tool. So make a little grid and just plot it. I definitely suggest counting not by ones on your y-axis. Tens would still be kind of doable, but I'd probably go with counting by fives with this 353 point right here. So something like that, except, you know, don't suck at drawing your cubic. Yeah, I mean, it's going to look something like this. So if it's no grid given, I guess you just sketch it like that. But she says on the same coordinate plane, so I'm assuming she's going to give you one. You ready?
No.
While we're waiting on Jasmine, I need to check something because the text blocked access to Google Sites, which I require for geometry, and they have 3 quizzes that half the people have to make up.
No, they will actually.
Can you read your directions to me? You don't know your directions? It's obvious which one the secant line and the function are. You don't need to label them. Your secant line is linear. Your function's cubic. They should be pretty much touching, because the secant line should go through it twice. Secant. Any others? Seriously? Seriously? 0. Is that less than or equal to -2? Is it between -2 and 3? Yes, it is. So what's 0 squared? 0 for A. -3, is that less than -2? So it's 5, because there's nothing to plug in. 3, is that less than or equal to -2?
No.
Is it between -2 and 3?
No.
Is it greater than or equal to 3?
Yes.
So it's 3 minus 7 is -4. Done. I'm not going to dignify that one with writing it down.
Okay. Next.
Which one's next?
The next one.
Seriously? Here's a graph I could have stolen right here. While it is the same set of equations, ignore it. You got more important things to worry about. You don't need those points. Those points are not necessary. The ones we just found. 0, 0, and whatnot. So start with the x's. We're going left to right, because whether you like it or not, you're in America. So -2 on the x right here. So that needs to be the equation y equals 5. And it's inclusive. So -2, 5. I have a horizontal line right here. If you don't know what y equals 5 looks like, well, go back to Algebra 1. Okay. And it goes on forever, so include the arrow, or you're wrong. Next, we need to evaluate our endpoints. Hey, plug in -2, we get 4. Plug in 3, we get 9. So I have the ordered pair -2, 4, 3, 9. Both of these are going to be open circles. -2, 1, 2, 3, 4. 3, 9, 1, 2, 3. 4, 5, 6, 7, 8, 9. It's x squared. You know what that mother function looks like. It's butts on 0, 0. That's a solid dot. And here, 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 here. That's all that goes right here, and this one keeps going up to there. Connect your dots. Don't suck at connecting your dots.
Oh, wait, we're going from the order?
That's how I find it easiest to draw. You just need to connect the dots in the shape of a parabola with the vertex at 0, 0. Now, we need our endpoint here. If we plug in 3, we get -4. That's going to be a solid dot, 3, -4. This is linear. Its slope is 1. So it's going to follow this path. Get your straight line drawing tool. IDs work wonders. Make sure you include the arrow. And don't put the weird line here that Noah put, because that would be wrong. Text still have not responded to my question.
How do you know the slope of that one?
Are you kidding me?
No.
She asked, how do I know the slope? If I look here, it's y equals x minus 7. Y equals mx plus b, cotton ball. M is 1.
Okay, that's it?
Yes.
Wait, what's the way range?
Oh, yeah, that's for that. Well, the domains looks like it's everything. Nothing's skipped here. Look here for the domain. It's everything less than there, it's everything between there and there, and it's everything greater than there, so nothing's skipped. Domains are reals. For the range, look at the graph. What's the lowest point you have on the graph?
The 3, -4?
-4. We're looking at range. Range is the
Up and down.
up and down, also known as the y values. Yes.
Bracket.
-4. Oh, yeah. If it's a bracket. And how high up does it go?
Infinity.
Forever. And this line says nothing skipped, so it doesn't even matter what's going on over here. We don't care.
Okay.
Let me check something.
We're doing that, right?
Yes, I'm waiting on you.
15.
Go touch the board. Quickly. Wow, really?
I do not remember how to do any of that.
It's transformations of the quadratic mother function. Now, your professor does it slightly differently than I do. It's fine. I do it her way because I saw your directions. And it works. It's just...
Would it work if she made different numbers?
I'm not guaranteeing it would always work. Like, the way I was thinking about it, I was like, does it always work? I don't know. Because she does the horizontal shift first. I'm not sure if that's always going to work. I just don't know. But yes, that's how she wants you to do it, so let's do it that way. It will get the same result on linear and quadratic. And she does not want the original mother function, right?
Right.
Do not graph the original. So we're going to start with the horizontal shift. Now, personally, I'm going to put the original mother function and put some light dots in pencil. Obviously, if I was doing it on paper, I'm not doing it on paper, I'm doing digital ink, but whatever. But I would suggest putting light dots in pencil and then transforming them so you can count properly, because we know you screw up counting, Cotton. That's just wasting way too much time. Moving on. So quadratic, what's your basic points for your quadratic mother function? That's 1. You need 3.
And the 1,
1, 1.
negative 1.
Yeah, let me make these dots bigger.
Negative 1.
Yep, negative 1, 1. So make sure you know your basic points for your mother functions. I don't know which all you might want to know, but for sure, squares, quadratics, you know, quadratics, cubics. Might as well know them all.
What did you do, bro? Open it up.
And we need to shift it to the left 3 units. So I'm going to erase those and move them over 3. So 1, 2, 3.
Okay, so we're doing that because of the plus 3?
Yes, x plus 3. That's a horizontal shift left 3 units. It says start with the first transformation. And your person wants to do horizontal shift first, vertical shift last. And I think she did stretches and then reflections. You have the list.
Yeah, I do.
I don't know what order she wants you to do them in. I think it's horizontal, stretch, then reflection, then vertical shift. Hurry up, Cotton Bowl.
I think I ran over SS stretch or straight, whatever.
Stretch compression. Next, yes. So we don't have any horizontal stretches or compressions because it's not in there with the X. We have a vertical stretch by 2 units. So we're going to take these same dots and we're going to double the Y values. So this is negative 4, 1. And I'm going to double the Y value. What's 1 times 2?
Okay, so what?
What's 1 times 2?
2.
2. And then we have 3, 0, 0 times 0. 0 times 2 is 0. And we got,
Are we streaking or stretching?
it's a vertical stretch by 2 units. Well, by doubling. And then we reflect it. So go to the board and reflect it. And then shift it down 4 units. Go, Cotton. Go to the board and do it.
Wait. How it's stretching? By 2.
Because it's outside of the X, so it's vertical. Vertical, you do what you think you do. It's times 2. Cotton's going to continue, and then I'll check her and scold her if she's wrong. Next, you need to do the reflection, then the vertical shift.
Down here?
finishes it down for you. There you go. Now now you just connect the dots. Like each time you make the little curves.
No, move it. Yeah, right now.
Make sure you have a round butt, not a pointy butt. Make sure they don't go on themselves, you know. Make sure it doesn't suck like these do. Yeah, whatever. You get it. And for the arrows. So we did this in Algebra 2. We also did it in dual enrollment, but y'all had the little slide bars for dual enrollment. Any questions on this one now?
I think I have 17, but
Okay, number 17. Use a graphing utility. So take this, plug it in your graphing calculator. Oh, it's a quadratic, right?
mm-hmm.
If it's a quadratic, you don't even need a graphing utility. 5, -3, 2. Moment, please. Let me double check and make sure this is still running. La la la, is the time running? Okay, still recording. Good. We're currently at 50 minutes and 50 seconds. Half of it's me waiting on Jasmine to find things. The other half's me waiting on other people to do things. All right. Mode 5, 3. Because it's a freaking quadratic, y'all. But it's not there. Where is it? What's the numbers?
5, -3, and 2.
5, -3, 2. We don't want the intercepts. We don't want x. There are no intercepts, as you can see, it's imaginary. We want the x value minimum. That's the x coordinate of your vertex, 3/10. And the y coordinate.
So it's going to tell you if it's minimum or maximum,
Minimum.
but it could also say maximum.
If the coefficient of x squared was negative, then it would be a maximum.
What if they do something different? What if they do what's the quadratic?
If you use a cubic, you need a different graphing calculator. Which I'll let you borrow one. So you just graph it.
How would we graph it?
On the graphing calculator, whatever it is.
Well, when we put it on the graphic calculator, though, like, how would we find out?
It depends on the calculator. Jesus.
18.
Wow, really?
Me too.
I'm guessing 19 too?
Yep.
So 18, we make the equation, 19, we plug in the numbers. All right, so we got the box problem. It's a square. 12 inches. I would suggest drawing it because you guys suck at visualizing things. There's my square. Actually, there's my square. And we're going to cut off the corners. How much of the corner are we cutting off, Cotton Ball?
Square? I don't know. Wait, hold on.
X.
Oh, I didn't remember.
So all these are X. X, 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 X. And original size was 12. So now, Cotton Ball, how long is this side that's got the X's chopped off?
Huh?
How long is the side now that we chopped those X's off?
12 minus 2x.
Yeah. And it's a square, so it's all 12 minus 2x. And if we fold up those flaps, how tall is it?
Wait, what?
How tall is this flap going to be? that we fold up.
12 minus 2. What?
The length right here is 12 minus 2x.
Uh-huh.
We're making a box, so we're taking it and folding it up. How tall is it gonna be?
Or divide by 2?
No, we're not dividing by 2, which I have no idea where you got from, but no.
What you're trying to say.
How tall will the box flaps be? Why are we cutting off these squares? So we can fold the thing. Look at this box right here. Your boxophile. So look, pretend this was a solid square before, or rectangle, and they cut off this right here, right? So they could fold it up. Solid rectangle, we cut off the square right here to fold it up. That's what we're doing right here. So how tall is it going to be?
Plus x?
X, just X.
Oh.
It's X tall. We're folding it up. So it's going to be a volume in the box, right? Let's pretend it's a metal box and we can put water in it. We're going to find out how much water we can put in the box. Or maybe it's going to be cat litter so you can use the bathroom. So volume of a box. How do we find it?
Height, length, width.
Yeah.
Multiply.
Multiply the height, length, and width. So that's going to be x for the height. 12 minus 2x. And yes, Abby, you could say that's squared, but we're going to go ahead and distribute, so let's do this. Why are we going to distribute? Because, I don't know, you might need to distribute. This is a perfectly fine formula. I don't know, maybe she wants it distributed, maybe she doesn't. We'll distribute it. 12 times 12 is 144. That's going to be negative 24. That's going to be negative 24. So that's negative 48. And that's x's. And then that's plus 4. And it's going to be x squared. However, we're multiplying everything by x. So that's going to be x. That's going to be x squared. And that's going to be x cubed. Multiply it all out. Or don't. I don't know.
Is it?
That's it.
Do we have to put an order or like the 4x?
There are no directions. So probably this would maybe even be acceptable. I don't know. Find the volume at the box. So plug in 3 for x.
Okay, well, if we plug in 3 for x, wouldn't it just be like with either of those equations?
Yes, plug in 3 for x. Oh.
I don't remember.
Me too.
Did it?
Yeah. Oops.
What?
I said inches squared, but it's inches cubed. It's volume, it's cubic inches.
Okay, look at number 8. You don't have to. So if I put, for both of them, said yes, it is a function because the x does not repeat. If I do that for both of them, will that be fine?
Well, the definition of a function is that each input has a single output. So for each member of the domain, there's only one member of the range. Something like that.
Each member of the domain.
There's only one member of the range.
Only one range.
For every input, there's one output. Exactly one output.
And what if they weren't a function? They would put there is not for every input there is.
Well, you'd probably give an example like if Lebu went to Chile and China, then you say Lebu has two different outputs, so it is not a function. Or if this was like y squared equals 9, then you'd say both 3 and negative 3, you'd give the order pairs that contradict it. Because it would be like 9, 3, and 9, negative 3, and that'd be two different ones. Can happen.
Guess I'm done.
Okay.
But you, well, never mind. Like this, I can understand it, but then if you put different numbers, I don't know how confident I would be.
Well, you better redo this thing a couple times because you have 1 hour and 15 minutes. No extra time. We're going to start at 11:50. We're going to end at 1:05. Because I got to have time to scan your stuff and send it to her. And class starts at 1:10.
Is your video, or do I have to do it?
I'm going to scan your stuff and send it to her instantly.
Okay. And you told me the time that you're gonna do it, so like you're gonna do it exactly.
It starts at 11:50, ends at 1:05.
Okay.
Monday. And like Friday, Saturday, Sunday. 4 days. Do y'all have any questions? Oh, you're not here, so you can't ask them. Too bad. Distance, midpoint. If you have questions about those, I'm sorry for you. Equation of a line, that's algebra 1. Equation of a line, that's algebra 1. Intercepts, that's algebra 1. Symmetry. So for x-axis, you plug in negative y and see if you get the same thing. You don't. Y-axis, you plug in negative x, see if you get the same thing. You don't. Origin, you plug in negative x and negative y and see if you get the same thing. You don't. So this one's not symmetric to anything.
Yeah.
And if you think about the square root mother function, obviously it's not symmetric. You should know that by visualizing it. Yes.
Huh?
You said, oh yeah.
Oh, you said that Abby didn't show her work for the symmetry.
Oh yeah, Abby didn't show your work for this number 5 right here. And okay, literally plug in negative y, plug in negative x, plug in negative x and y, simplify, and see if you get the original thing back. On none of those you will, so no. Fine, we'll do an example that you actually will have symmetry. Let's say y equals x squared plus 5. Okay, I can see this in my head. It's symmetric to the y-axis. But seeing it in your head is not showing your work. So, let's start with x-axis symmetry. To see if it's symmetric to the x-axis, you replace y with negative y. Solve for y. It is not the same as the original, so that's a no. Y-axis. You plug in negative x. Simplify. And as you can see, it is the same as the original, so that's a yes. And obviously it's not symmetric to the origin because we get the same thing we got right here. Because that's going to just be the same. It's going to be x squared. So we divide by the negatives, it's going to be the negatives. So origin's a no. You do the same work. You'd have negative y equals negative x squared plus 5. And it's not going to work. Okay, done. Another example. Let's try that. So if I plug in, again, we're going to x-axis, y-axis, origin. For the x-axis, I plug in negative y. Divide by negative 1, and it's not the same. So that's a no. For y, we plug in a negative x. And we get negative x cubed minus x. Again, not the same as the original, so that's a no. For the origin, we plug in a negative both. So I'm going to simplify the right side first because, oh, hey, I already have it right here. Then I'm going to divide through by negative 1. Hey, look at that. It's the same as the original, so that's a yes. And that's how you algebraically show your work. So, Abby, you can't just say yes or no. You have to actually algebraically show your work because it says so in the directions. The square root, that don't work. Any other questions? Now that we have an hour and some long video, and I have 5 minutes to get my stuff ready for 7th hour. No questions? Good. Goodbye.